Hello, this is just a walkthrough on this leak code problem. Well, it's not really leak code, but it's very similar to Leets code. It's a website called HackerRank. It basically gives you programming problems and you solve them. It's very similar to Leets code, but the problems here are generally harder than a lot of the ones on Leets code. So we're given this question. It says, we're given this square grid of characters. They're ASCII characters from A through Z. They want us to rearrange and sort them uh, alphabetically in ascending order, and then determine if the columns they create together are also in alphabetical order from top to bottom. And we simply return yes if they are, and no if they're not. So, just for example, here we're given these, and you're supposed to basically sort them. Well, here I guess they're already sorted, but you just check from the column side. So E, is that sorted? Yes. B, D, F, yes. And C, E, G. They're sorted because they're in ascending order. They're essentially in alphabetical order. And they're also in alphabetical order from left to right in each one of them as well. And since they are, then the answer for this example would just be yes. So all we're given as a parameter is this vector string. This is just what runs the test and other things. So we don't have to worry too much about those. Okay, these are the constraints. It's an example of what you're being tested against. So this one would be yes. And here they're not sorted and they become sorted. Essentially, okay, so here they become sorted and then you just check them one by one. Okay. So this is where we're gonna do the work. I'm just gonna create a little bit of space so keep myself organized. So this is a vector, which is just a sequence of separated elements, a container of separated elements, I should say. And we need to sort each one of those elements, which is a string. So essentially, it's a vector of arrays because strings can be treated like arrays in C++. So it's a container that holds container of characters. So I need to sort that. So I'm just going to create a for loop. And we can just say auto, which will automatically deduct the data typed and use it. This is just a for loop. And in here, at every single item, we're going to call the sort STL function. So we're going to sort from grid begin to, oops, to grid and and that's going to sort all of the, oh, excuse me, it's not grid, it's X. because X is a string. So we're sorting every single string. We're calling the sort function on X, which X is every instance of each item in this vector. And we're sorting each item in the vector by calling sort on the items. And obviously, the items are a string. A string is just a sequence of characters. Like, just in case you are not familiar, this is a string, or like, this is a string of characters. And then for the next part, when we're going to check the actual columns, there's multiple ways to do this, but one that might be helpful is probably going to be like a lambda. So we're going to create a lambda function. We're essentially going to use another STL method. Um, so we're going to use adjacent find. This will find two items in your list that match what you're looking for. So it needs multiple parameters for this STL function. So first we need to tell it its beginning point, which in this case it would be grid at begin, and then grid at end is its ending point. That's the second parameter. And then for this third parameter, you can pass it a condition, like it must follow this condition for the actual logic of what you're looking for in the function. So essentially, you're creating a condition that it needs to follow. And here's where we're going to use our lambda. So it's essentially going to overwrite or overload an operator, a Boolean one specifically. And what we're going to do in here, sorry, this thing is in the way. Um, we're going to go ahead and grab the elements that we need and just create a definition and then return something from it. It's kind of like an instance of a function. You can think of it like that. So basically, it's just a function that we're just going to use for this one thing, and that's it. Um, Essentially, what we want to do here is we don't want to modify our strings on accident. So we're going to do constant and then string, because that's the data type. And then we can just create a variable like a. Oh, looks like I misspelled that. All right. And then after that, it's the same thing, but for the other variable. Okay, I don't know why I misspelled that. All right, so these are our variables that we can use, which are being passed down by each call to adjacent. So remember, we're checking every pair from beginning to end where this condition on the third parameter is met. So these are first two parameters, and all this is our last parameter. We're still going to write a lot more here. So once we have the two strings that we're interested in checking, we are going to go ahead and call another function in here. And this one is going to be mismatch. So similar to adjacent, it also will essentially use lambda, like so. And we're also going to assign it a variable. So this one we can just call it p. Okay, so here, okay, not the char yet, but here we're essentially gonna use the things that we got from the first strings to create the lambda action here. The next one, I should say. So basically, here's gonna be a dot begin, then a dot end, and then we're gonna compare that against b because that's where the other string lies. So it's gonna be b dot begin, and we actually don't need the end part of this because it's actually comparing a against b. So those are our first two parameters, and like I said, we're gonna have a third one. So here again, we're gonna have the lambda. So I need a semicolon there and another one here. Okay, and here's our next lambda start. So essentially, I would like to quickly explain what mismatch will do. Mismatch will look for a mismatch in the string of A that we got, and it's going to compare it to B. So it's essentially grabbing these and comparing them like with each other. It's a sequence of characters, comparing it with another sequence of characters. And to do that specifically, we're defining how we want that comparison to happen with lambda, which is this. And like I said before, lambda is an instance, or you can think of it like an instance of a function. Um, and here we are going to be using chars because the strings are composed of chars. So we can call this char x, char y, and then here is where we're going to define the comparison. We're going to want to return the comparison of x. We're going to check if x is smaller or equal to y. And if it is, then we're returning true. All right. So that should do the trick for this one. But as you can see, we haven't returned anything for result, for adjacent, sorry, into result. And we haven't used this result that we got from here. So we're going to go ahead and return now. We're going to return basically P first. I'll explain what that does in a moment. So we want to return if it's not equal to end here. I think it's not equal to grid. No, if it's not equal to a tab begin. Yeah, because I'm sorry, a dot end. Because if we didn't reach the end, that means that this exception happened at some point. So there was a mismatch, and we didn't reach the end. That means that we're gonna return a no, basically. Um, so let me just make that look a little bit nicer. All right. There we go. And then result still not being used because we need to return our answer. Hopefully it's correct. We're going to return the actual result, but we're going to, since we're being asked to return like a string, yes or no, if we reach the end of grid, then we can go ahead and return yes. So, okay. So result, I believe it's let's see. So it's capitalized. Yes and no are capitalized. Okay. And like I said, we're checking if grid at end is equal to result. Um, hmm. Okay. So I'm just missing the ternary operator. So if this is true, if it's at the end, then success, like we can return yes. If not, that means there was a not sorted comparison between these two strings. A not alphabetically sorted, I should say. And I do believe that would do the trick. Let's try it out. Yes, so it did work. This is what we were tested against, and we essentially printed a yes. So now let's try running it against more tests. Great. You can also just compare strings using this, like, and a for loop, but this is just honestly safer to do, and you make less mistakes. And that's it for this one. So this one was essentially just a problem where you're giving an array of strings and you have to determine whether they're sorted by columns and by rows as well. You have to sort them first. And thank you.